This video, we are going to perform operations on numbers written in scientific notation. These are like problems from the textbook 12.2, numbers 97, 99, 101, 103. That's it. This is one of our applications of our rules of exponents that we have been talking about. So let's go ahead and get started. First is 1.9 times 10 to the negative second times 4 times 10 to the negative third. So we're going to multiply the parts that are like. Remember, a commutative property of multiplication says if this is all multiplication, I get to multiply in any order that I want to. And associative property says I can reassociate things. So I'm going to multiply these parts that are not base 10 together, and I'm going to multiply the parts that are base 10 together. The parts that, shouldn't say these aren't base 10, but you see what I'm saying, the parts that are not exponential with the parts that are exponential. So 4 times 9 is 36. 4 times 1 is 4, plus 3 is 7. We have one decimal point there, so it goes there. And this is going to be times 10 to the negative second plus a negative third. When I multiply like bases, I add the exponents. 7.6 times 10 to the negative fifth. And that is correct for scientific notation. Scientific notation is going to have a non-zero number, a significant digit, we call it, to the left of the decimal point, just one significant digit to the left of the decimal point. All other significant digits are to the right of the decimal point, and times 10 to the power of some exponent where the 10 to the power tells us the place value that this number was in. So because this is 10 to the negative fifth, this was in the 100,000ths place. So this is 7.6 100,000ths. Or 76 millionths. All right, let's go ahead and look at our next problem. 6 times 10 to the negative ninth times 7 times 10 to the negative eighth. And then we want to write this in standard notation. When we're done, I'll go ahead and write this one in standard notation as per the instructions as well. So there's going to be 4 zeros here. And this is what I was just talking about: tenths, hundreds, thousands, 10,000s, 100,000s, millions. So that's 76 millionths. This is 42 times 10 to the negative 17th. When my decimal point is here to the right of the 2, when I move it back 17 places to the left, there's going to be 15 zeros in front of that 4. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 4, 2. It looks like that. It's a lot of zeros. You see what the advantage to writing in scientific notation is. This actually would be written as 4.2 times 10 to the negative 16th when I wrote it in scientific notation, because I want that first significant digit to be to the left of the decimal point with all other significant digits to the right of the decimal point. And we have 7 times 10 to the negative first over 35 times 10 to the second. This is going to be 7 over 35 times 10 to the negative first over 10 to the second. We're not trying to make positive exponents here. We're trying to get everything into the numerator. So this is going to be 1/5 times 10 to the negative 1 minus 2 is 0.2 times 10 to the negative third. Notice I have a 0 as my first number here to the left of the decimal point, and that's not a significant digit. So if I were to write this, I would write it as 2 times 10 to the negative fourth, like that, so that I would have a significant digit to the left of the decimal point. That's scientific notation, but this is going to be 0.0002 in standard form. I've taken this decimal and I moved it 3 places to the left, so I have 3 zeros in front of the 2. Let's go ahead and clear my whiteboard. I have 0.8 times 10 to the negative 7th divided by 2 times 10 to the negative 4th is going to be 0.8 divided by 2 times 10 to the negative 7th over 10 to the negative 4th, 0.4 times 10 to the negative 7 minus a negative 4, 0.4 times 10 to the negative 7 plus 4, 0.4 times 10 to the negative third. Again, that's not correctly written in scientific notation. So that would be 4 times 10 to the negative fourth, like that. But we'll go ahead and deal with it this way since we're writing our answer in standard form. Move this decimal point back 3 places to the left, and we have 0.0004. All right, that's it for our problems on scientific notation. So we'll come back next time and start talking about polynomials. See you for the next video.